Stephen D. Baker. Stephen joined Rockler in 1995 and worked for several years prior to that as an engineer in local government and consulting. He's been actively involved in the technical development of most of Rockler's water quality products and is now Rockler's water quality manager. So please welcome Stephen to the stage.
Thanks, Brad. That's me. This is a presentation that I did, or part of a presentation I did in New South Wales for the 20th anniversary, representing the manufacturers, and it's the part of it that represents a bit of a roadmap towards the validation process. What I've put down here is it's an acknowledgement that I agree with everything that Charles and Mick has both said, insofar as at the moment we're getting to a point where we really do need some guidance and we need to be pushing in the same direction. Now, what I've done is I've gone out and attempted to define a validation process based on some very reputable documents that we currently use in Australia, such as the Australian standards. I've been on various Australian standards committees, and even though they have very specific focus, most of the Australian standards, they all follow a very unique or a very common format for how they define the problem. What they do is they define the problem first. Now, I think the industry needs to step back a little bit and see exactly what the problem is that they're trying to solve. We're talking about quite technical engineering problems here, so we need to define the problem probably pretty quantifiably. ARQ, the document that was put out by Institution of Engineers Australia as a secondary document to AR&R, goes a long way to defining what the parameters are in runoff quality, so we get a bit of a feel for where those are, but I think we need to go further than that. We also need to set out the objectives of what we're trying to do, okay, which is exactly what the Australian Standards does. It needs to define a way of managing data. There's a lot of data out there that's by a lot of different sources, private, public. It's not shared very much, not access to it. I think we need to find ways of managing the data and doing something with it and giving ourselves some control. Reporting formats. I think some of the problem as well is the fact that there's a whole lot of different ways of reporting information and it's not consistent, so you can't compare apples with apples. Very important also is the means of demonstrating compliance. Now, I think at the bottom of all of this, it's all very well to say something, but how do you actually, once something's installed or once something's been designed and there's a performance criteria hanging over the head for certification, how do you actually demonstrate that it's complying with the requirements? That's important, and Australian standards are very, very good and very, very strong in that aspect of what they provide. Sorry. Certification also is, once you've demonstrated compliance, you need somebody to certify the design and take responsibility for it. There is far too many cases in the industry at the moment where it gets to site and a contractor says, oh, I don't want to do that, I'll put in whatever I want to put in, and that's the end of it. So who takes responsibility for that? Well, the consultant can't take responsibility for it anymore because it's not their design anymore. So who takes responsibility? So there needs to be a way of drawing a line under it and saying that's exactly what we wanted and that's what's been executed. Okay, so all this has been defined in Australian standards in a certain way, but we need to take that format and do some work ourselves. Okay, define the problem. Aesthetics in a stormwater system, what are we trying to protect? The aesthetics, harmful to humans, fish, plant life, downstream processes. Not every project is the same, they all have their own criteria, so we need to have a way of defining what it is you're trying to do and therefore have project-specific requirements. Having one size fits all is not going to work. This is not a reality television show. The judges are not going to tell us what the right answer is. We have to take responsibility for each project and look at the parameters with all the data presented in a common format and assess it for ourselves. What causes these problems? Is it gross pollutants, TSS, TN, TP? Not all problems occur on all sites. Not all projects justify the rigour that's necessary to remove some of these pollutants from stormwater. We need to be pragmatic about it and work out exactly what our problems are. We also need to categorise the particular problems based on their physical characteristics. Some of these processes or some of these pollutants can be removed by very similar means. It's just a physical process, heavier, lighter than water, etc. Some require very complex chemical processes to remove. We need to categorise them on a very similar basis and compare them that way. Set out objectives. What are we trying to achieve by undertaking validation testing? We're trying to measure performance relative to target pollutants. We've got to have quantity figures. It may require information sharing. So I know that some information that gets derived is proprietary information and people don't like to share. I know that Sydney Water, for instance, in Sydney has been doing data pollution monitoring for many, many years but refuses to share the data. They use it for their own internal purposes. Now I think that is very immature and I think the industry needs to move on. Start sharing the data and working together. Bottom line on this one is the objective of the validation process is not to actually compare the devices on a general basis, but is to derive a mechanism to allow comparison by qualified people on a job-to-job basis. Okay? So you can compare apples with apples on this job. What is appropriate on this job might not necessarily be appropriate on that job. Data management. There's a lot of data out there. Some good, some bad, and some absolutely pointless. What we need is a way of assessing that data, working out what is relevant, what isn't relevant. Okay? A lot of bad data can be thrown into the mix just to confuse everybody so that you actually miss the point of what's actually trying to be achieved. We only need good data, relevant data presented in predetermined formats that the protocol will actually define what is good and what is bad. So we need to establish minimum data set sizes for statistical significance. Very good scientific method, which is not unusual. Science does that every day. Reporting format. This is another thing that I think will go a long way towards making it a lot clearer to the industry. We need to be specific what we want to see. Do we need PSD curves? Do we need removal efficiency versus flow rate? Do we need to see music transfer functions, not just interpreted generically, but be specific? Again, they shouldn't actually compare products per se, but establish a format to allow comparison on a job-by-job basis. What's appropriate for one job might not necessarily be appropriate for another. Now, as I said, this is the most important part of the whole protocol. It doesn't matter what you do in design, it doesn't matter what work you've done before, by the time that gets to the site and it doesn't get put in the way it was designed, you can forget about it. The consultant's work has been wasted. The protocol has been wasted, all the information that's been gathered in the process has been wasted. If the contractor puts in something completely different, forget it, all bets are off. So we need to work out a way of demonstrating compliance of what goes in the ground and what's been designed actually does achieve the objectives that's been decided upon. Australian standards do demonstrated compliance very well, but it is very difficult to come up with something that's consistent, something the industry can accept. It also needs to be reasonably simple, relatively cheap, and it needs to be indicative of the objectives that you're trying to achieve. And unambiguous is probably also pretty important. And obviously it needs to extend to the installing contractor, even by saying that we done?
Might stop you there.
Okay. Last point. Certification. After all this is done, someone should be able to. It should be comfortable enough with what has actually been achieved to be able to certify it. So a professional in the industry needs to be able to certify that is what's been achieved. And it could be certifiable under some sort of QA type system. Okay.
Thank you, Stephen. Any questions from the audience at all? Oh, very quiet. Someone has a burning question they'd like to ask? I could ask one. Stephen,
yeah.
Obviously there's Australian standards for a whole bunch of stuff.
Yeah.
How come we haven't got an Australian standard already for storm quality?
Okay, good question. Australian Standards is a publishing house.
Yeah.
No one has actually demonstrated to Australian Standards that there's actually a need for the standard. So if we go out and produce our own document in a format that's consistent with what they do, and all of a sudden, hey presto, it becomes popular and becomes working and the government start to acknowledge it and they start to get regulations based on it, I reckon Australian Standards will step up and go, hang on, we want to put a technical committee together. That's how you do it. It's a political animal.
So good if I think there's a lot of backing it too.
Yes, well, financial backing as well is very important. But it is a publishing house, that's all it is. So we can do everything for them. We can provide the format for them, we can do all the work and actually publish the document ourselves. And if there's support for it, I think you'll find Australian Standards will take it up.
Thank you very much, Stephen. Thank you.